This video will be on problem 19.4. It's a good example of chapter 19, how with the stories they give us, we have to pick out all the parts and make a graph, and then we can write our function in the standard sinusoidal form, which looks like that. So it's really a matter of reading the words really carefully and drawing the graph and really trying to understand what it says. And drawing the graph is actually super important to that first. So let's look at it and see how that works. Okay, so the question is, suppose the high tide in Seattle occurs at 1 a.m. and 1 p.m., at which time the water is 10 feet above the height of low tide. Okay, and then, all right, let me just read the whole thing. Low tides occur 6 hours after high tides, so it's right in the middle. Suppose there are 2 high tides, 2 low tides every day, and the height of the tide varies sinusoidally, so that means we can use that. Find a formula for the function that computes the height of the tide above low tide at time t, and y equals 0. In other words, y equals 0 is low tide. Okay, so y equals 0 is low tide. So, and then the height goes up to 10 feet, so it goes 10 feet above low tide, 10 feet down. So the tides vary by 10 feet. Okay, you got to be careful now, that's not the amplitude. The amplitude is in 5 feet, because the middle is 5 feet, and it goes 5 feet up to 10, and then 5 feet down to 0. Does it make sense? The average would be 5 feet, goes up to 10, down to 0, average is halfway in between. So what they gave us is the peak to peak. The bottom peak, the trough is 0, the peak is 10, so amplitude is 5. If I said that enough, I think I have. So our D here is going to be 5, okay? And, sorry, yeah, the average is 5. And the amplitude is 5. It goes, starts, middle is 5, goes up 5, goes down 5. So both A and D are going to be 5. So I can write that. So we know A equals 5, the amplitude is 5, and the average is 5. So it goes up to 10, down to 0. Okay, then time. Okay, time is with 12s and repeating and everything. And when does time start? When is 0 time? Time gets really confusing. So often then it's nice to pick a 0, and 0 at midnight kind of is the 0 time, right? Midnight, we start the day over. So we're going to say that midnight, which, okay, is that 12 a.m.? I think that's 12 a.m. It's like it switches there, right, from p.m. to a.m. So we're going to say midnight. I'm just going to write it as midnight would be 0 o'clock. Okay, so that would be 0 o'clock, o'clock, 0 time. And then we'll just keep going and going and going. We're not going to stop at 24 hours and start over again. So 48 hours would be day 2, 72 hours would be day 3. So much easier. And then we know what we're talking about, just time and hour, starting at time 0, which we're going to say is midnight, which is normally what you do. Okay, that way we can get rid of the AM, PM thing. Okay, so that's one other trick. Now, let's draw our picture. So, I'll draw it here. So we're going to start at time 0, so I don't need to have anything negative here. And I don't even need to have below this the axis, because everything is going to be above, right? Because we're going to go down to 0, so I don't have to have the negative part. I'll make a little bit of negative there just to show that I thought about it, but nah. Okay. Then we're going to put the average at 5. So let's make 5 about right here. So that's 5, and then 10 would be here. That's the peak. Okay, and it's kind of nice. It actually helps to put the line up here. So I'm going to put a line right there, and maybe a line right here. Okay, what else now? Oh, and then a high tide occurs at 1 o'clock in the morning, which is time 1. So this is time 0. I don't need that, so 0. So let's put, okay, we're going to need a lot of times here, right? Because we're going to have to go to 24 as a full day. So there's 2 high tides and 2 low tides. So I need to get all the way to 24. So I'm going to put maybe even beyond 24. So I'm going to put 24 here. Do they ask us anything about 2 days? We got to make sure we fit all the time in here. No, I think if we go up to a full day, we're okay. So I'll go a little bit further in the day. So that's 24. In the middle is 12. So this would be 6. So this would be 18. So this would be 3. So this would be 9, 15, 21. Okay, so this would be then 1 and 2. Put those little dashes in there to make sure we get those right. Okay. It's kind of awkward doing 3s, right? You kind of have to guess what a third is, but. All right. So, at 1 o'clock, it's high tide. So, I'm going to use a different color here. So, 1 o'clock is right here. It's all the way up here. Then, at 1, that's 1 a.m. And then at 1 p.m., which is like 13 o'clock, right? 12 plus 1, 13 o'clock, which is right here, it's high tide again. So it goes up to there. Halfway in between, it's low tide, or every 6 hours, right? 12 hours apart, that's 12. 1 plus 12 is 13. So 1 plus 6, it's 7 o'clock. Well, that's a bad mark there. Should be more like here. Anyway, it's 7 o'clock. It's low tide. So that's going to be at 0. We go all the way down to 0. And then 6 hours after that, so 13, so 19 o'clock, it's low tide. And if we kept going with that, 6 hours, every 6 hours, right? 6 hours low, 6 hours high, 6 hours low, 6 hours high. Let's do one more. 19, so 25 o'clock, which would be about right here. So 25, it would be a high tide. That's probably good enough. Now we try to draw a sine wave between those. It helps actually to put the middle of those. So see, between 1 and 7, it's 3 and a, oh, that's awkward math, isn't it? No, we'll add 3 hours, so at 4. At 4, it's going to be in the middle. Add 3 hours. At 10, it's going to be in the middle. That was 11, so 14, 11. Did I mess up here? No, 1. So at 14, 1 plus 11. Okay, 13 o'clock plus 4 at 13 o'clock, 16 o'clock. That's what I was trying to say. It's in the middle. 3 hours more. It would help if I put the numbers there. 13. 19 o'clock, it's here. So then, what, 22 o'clock? It's in the middle. It helps to have those middle ones to draw the wave. Okay, now I'm going to try to draw a sine wave to connect the dots. So this is a peak, so it kind of went like this. So it kind of goes down here, bottoms out, goes up, bottoms out, bottoms out. Okay, something like that. Of course, it keeps going. That's pretty good, huh? It's not hard to draw good waves and good pictures if you just draw the graph kind of carefully. I didn't need graph paper. Graph paper would help, but I don't have a graph board. But you don't need one. That's pretty good. Kind of helps us figure stuff out. Okay, so now we have to figure out everything else. That's our picture. So we got, if we know what A is, 5, we know what D is, but what is the period? Okay, the period is a full cycle. Okay, they kind of told us, which is from peak to peak, from here to here. That totally works. We know that's 12 hours from 1 o'clock to 13 o'clock. So the period then is 12. Right, that's 12. Or we could go from here to here, which should be 12. That would be from 10 to 22. Yep, that's 12. We could go from trough to trough. Lots of ways to tell the period. The obvious one is they tell us the period is every 12 hours we have a high tide. So yeah, that's the period of the tides. Okay, so we know that B is 12. Okay, so B is 12. The hardest one always is C, the phase shift. Okay, and the phase, it's always where the wave starts, which is right here. That's the first full cycle, right? It's when the word starts going up, because a sine wave is always starts here and going up. So we want to see that point, the first point we have, because there are an infinite number of numbers for C. We find a C, and then it can always be that plus 2 pi, or that minus 2 pi, or plus 4 pi, or plus 6 pi. We can keep adding multiples of 2 pi because sine waves have a period of 2 pi. And since the period is right here, this number in here is always 2 pi because of the way we wrote it here. Okay, so it can always be the period plus 2 pi. Oh, wait. I think I said that wrong. Sorry, I think it's the other way around. This number here, the phase shift, okay, we'll get the phase shift first. The phase shift can always be, yeah, I was backwards there, can be the shift itself plus the period. Okay, the normal sine wave is period 2 pi, so that's what I was saying about 2 pi. But in this case, the period is b, which is 12. So any number here plus 12 would work. Okay, because like here it starts going up. That's at 10 o'clock, it starts going up. But it's going to start going up again 12 hours later. So if we go 12 hours later, here it is, right? At 22 it starts going up. So the phase could be the initial place plus the period where it all starts happening over again, since our period is 12. Okay, anyway, I think if we do the phase, I'll be quiet, so let's find the phase now. So the question is, how far is this point shifted from 0, right? This is the first place where it starts going up. How far is it shifted from 0? Well, it's clearly shifted 10 from 0. It's shifted to the right 10. And normally you draw the wave in the positive place, so it makes sense it'll always be shifted to the right, which means that C then would be 10. Okay, now getting back to that, if I put C equal 10 plus 12, well, that's saying how far this is shifted. And that's okay, which would be 22. I could also say that C was, it's about 22. We could also say, boy, I'm having trouble with 22 today. That's 22. We could also say that it would be that plus 12, which would be 34 or 46. We could keep adding 12 and put that in here, and it'd be technically correct. Okay, it would give us this exact same wave. We could take away 12. We could say it'd be 10 minus 12, which would be negative 2, and we could put a plus 2 there, and that'd work too. Normally, though, we choose the first one to the right, the very first one to the right. We keep it minus the first one to the right. That way we know how far it's shifted to the right. It's just the easiest, and again, it's like we all agree that that's the best way to do it. So the best answer would be 10, even though all these others are possible answers. Just keep adding the period, keep adding the period. And problem number 2, they talk about that. They say give 4 different possible values for the phase shift for C. You find the normal one, and then add the period, add B to it, and you keep getting more. All right, anyway, enough talking there. We are done. Now we just have to write out our thing. So we have the height at any time t we want is a 5 sine 2 pi over the period, which we know is 12 hours, times time minus 10, because that's our phase shift. It's shifted over 10 hours, plus the average was 5 also. And now we can plug in numbers. So now then they say part B. What is the tide at 11 a.m.? Okay, 11 a.m. is time 11. That's nice. If they had said like 5 p.m., it'd be time 17, or military time. And then we're just going to keep going. If we did time 25 as the next day. Okay, so you plug in 11 here. So that would be 1. So it'd be 2 pi over 12 times 1. So that's just 2 pi over 12. Take the sine of that, multiply by 5, add 5, and we can get what the height of the tide is at 11 a.m. I'll let you guys do that. The answer is probably in the text. Make sure your calculator is in radians. Okay, biggest problem there. Make sure your calculator is in radians. Now we could guess, and what's always good is when you get an answer, see if it looks right in your picture. That's the nice thing about a picture. At 11 a.m., what do we think it is? Here's 11. Okay, here's 11 right here. So we know it's going up, tide's going up. It's going to be higher than 5 feet, maybe 6 or 7 feet, depending on how I did my picture. My guess is about 7 feet. So try plugging in. T here is 11, which that makes out a 1. Take the sine. Again, my guess is you get about 7. If you get 3, we know something's wrong. Either my picture's wrong, and I don't think the picture's wrong, so probably did something wrong with the math. Okay, that's, again, the good thing about a picture. You can see if you did it wrong. Okay, a lot of the problems in chapter 19 are like this. You read the thing really carefully, pick out the top, the bottom, the middle. Where does this start going up? That really, really helps to have a picture for that. So get really good at drawing a picture like I did up here. Most of you could probably draw much better pictures, which is awesome. Okay, good. Thanks for listening.